In this video, we'll briefly go over the major types of reaction that this course will want you to know. The first type of reaction I've given you, you may be able to see, has two reactants. Those multiple reactants come together to make one product. Any reaction that has multiple reactants but only one product is called a combination reaction. You may also see these called synthesis reactions, but that means the same thing. The opposite of a combination reaction is the next reaction I've written, where we have one reactant but multiple products. We can see here water is breaking into hydrogen and oxygen gas. Any reaction where you have one reactant but multiple products is called a decomposition. Think of that as the opposite of combination. The next type of reaction has water gas going to water liquid. Here you can see the chemical composition has not changed at all, only the state. We've gone from gas to liquid. We can call this a physical change because no chemical bonds were broken or formed. Specifically, this physical change is a change in state where we go from gas to liquid, also known as condensation. So bear in mind that a change of state is only a physical change, not a chemical change. Here are three more reactions that may be more difficult to spot. In our first reaction, we have a compound that is composed entirely of carbon and hydrogen. This is called a hydrocarbon. Notice this hydrocarbon is combining with oxygen gas, O2, and it is making a mixture of carbon dioxide and water. Any reaction that has a hydrocarbon combining with oxygen gas and yielding carbon dioxide and water is called a combustion. In layman's terms, this just means you're burning fuel, where the fuel is the hydrocarbon, and the oxygen is representing that we're burning it, because in order to burn anything, you have to have oxygen. The products of that burning are carbon dioxide and water in the case of complete combustion. If you get other products than carbon dioxide and water, that is called an incomplete combustion. Our next reaction has HCl, which is a compound, added to a single element, that's sodium. Notice on the right side, we still get a compound and we still get a single element, but the compound is different from before. Previously, our hydrogen was connected to chlorine, but in the product, the hydrogen is now the single. Effectively, the sodium has come in and replaced that hydrogen. When you have a compound and a single becoming another compound and another single, this is called a single replacement. Some people will say the word displacement instead, but it means the same thing. A similar reaction is where you have two compounds that both make changes. We can see on the left side of this, we have two different ionic compounds. On the right side, we have two different ones. Let's look at what happened here. We used to have sodium connected to the PO4. But on the right side, the sodium is connected to something different, the ClO4. We also have aluminum connected to ClO4 to start with, but at the end, the aluminum is also connected to something different. Effectively, what happened is that the sodium came in and replaced the aluminum, so that now the sodium is connected to ClO4. While this happened, the aluminum switched around too and connected to the PO4. So the aluminum and sodium changed places. But since we still have two compounds as our product, this is called not a single replacement, but a double replacement. Some people will again use the word displacement. Also, occasionally you'll hear the word metathesis in regards to this reaction, but that just means the same thing as double replacement. Again, you may not see the word metathesis in your class, but if you ever read it later, that means pretty much the same thing as double replacement in the context of most of these reactions. Thank you for watching, and we'll see you again soon.